Greetings, I'm Alex Rusakovsky from Treviso, and I'd like to present our joint work with Lax Lakshmanan from the University of British Columbia and Vaishnavi Sashikant from Oracle, named What If OLAP Queries with Changing Dimensions.
Et si tu n'existais pas, dis-moi pourquoi j'existerais.
Well, people write songs about what-if situations. Our contribution is slightly different though. We think perspectives are key to analysis of hypothetical changes. We propose a novel notion of perspective cube and develop techniques for its efficient computation. We implemented our techniques on the S-based OLAP engine and conducted a series of experiments that demonstrate the effectiveness and scalability of our strategies. As an illustration, let us consider an organization whose employees are classified as full-time, part-time, or contractors. Organizational structure as of January is shown here. In February, Joe goes part-time and George is hired. In April, Joe becomes contractor and Tom takes time off. In June, Joe resumes as full-time, Tom returns, but Lisa resigns. Changes are not necessarily time-based. It may happen that at a different location employees are classified differently. So what business problem are we trying to solve? Suppose we'd like to analyze the variance in compensation expenses for each employee group in order to improve budget allocations. Consider existing and hypothetical changes to organizational structure and its impact on compensation. Typical questions to ask are: what if the original structure never changed throughout the year? What if the original structure were preserved through May and then changed as in June? What if Lisa were a part-time employee in April and May? The first two questions are examples of negative changes. We assume that certain changes did not happen. The third question is an example of a positive change, something that never happened in reality. We assume familiarity with certain OLAP terms like cube, dimension, hierarchy. The other hierarchies in the cube we'd like to consider are time, location, and measures. Standard language for OLAP queries is MDX, and this is the query we're interested in. Notice that the data returned from the query has three instances of member Joe, which we will distinguish by their appearance. Dimension whose structure changes is called varying, and dimension driving the change is its parameter dimension. A varying dimension can have several parameter dimensions, and there may be several varying dimensions in the cube. In a varying dimension, every member instance has a validity set, which is defined as a set of all leaf-level members of the parameter dimension for which it is valid. For the instance FTE Joe, the validity set is January and June through December. For the instance PTE Joe, the validity set is February and March.
If a man could be two places at one time, I'd be with you.
Well, unlike in the song, in our world, the validity sets of different instances never intersect. Perspective is just a subset of the leaf level of the parameter dimension. As will be explained shortly, perspectives can have several semantics. Forward and backward in particular are valid when the parameter dimension is ordered. If a query uses perspectives, aggregation mode can be visual or non-visual. Perspective queries add an additional clause to the regular MDX query. Here is an example of the perspective query. Semantics of a perspective query is best explained for a single member perspective. We first exclude those instances whose validity sets do not intersect with the perspective. For static perspective, there is no other change, and with non-visual mode, aggregated values are taken from the original cube. When visual mode is used, derived values, shown in red, are recomputed after applying the perspective. Just as in the previous example, Perspective April filters out instances FTE Joe and PTE Joe. Interpretation of the dynamic forward semantics is the following. What if organization was structured as in April, and changes after April did not happen? Notice that the values after April are taken from another instance of member Joe. Dynamic backward semantics has similar interpretation. What if organization was structured as in April and changes before April did not happen? As in the single member case, multiple member perspective excludes those instances whose validity sets do not intersect with the perspective. Like before, static semantics leaves leaf-level cells untouched. Forward semantics extends the validity set of an appropriate instance until the next member in the perspective. Similar logic is used for backward semantics. Interpretation is the following. What if the organization was structured before February, as in February, and between February and June, as in June, and no other changes before June ever happened? Values for the leaf cells are relocated from the other instances.
Imagine all the people sharing all the world.
Well, perhaps we cannot share the entire world, but if necessary for analysis, we can make even all our members hypothetically share the same employee group. This is called positive change. To describe positive changes, we need a relation which explains how the instance changes its parent over time. Positive changes also add another clause to the regular MDX query. A generic what-if query combines negative and positive changes. The result, after aggregations, is called the perspective cube. We introduce an algebra that describes the perspective cube and prove that it can express any perspective query. Efficient computation of the perspective cube is not a trivial task, and we propose an algorithm using chunking and graph pebbling techniques. Details can be found in the paper. We implemented perspective cube computations using S-base OLAP server, and our experiments prove the efficiency and scalability of our approaches. No, our results are not likely to make us rich, but organizations using our approach can improve their performance. And thanks to Joda Sen, Brett, Abba, and John Lennon for helping explain the concepts of what-if analysis.